So moving on to the next concept, we have calculations of concentrations. And there's three ways to calculate these concentrations really quick. They're up here on the board. I'd write them down. First, we've got percent concentration. Then we have something called parts per million, which is oftentimes referred to as just ppm. And then the last one, which is a really important one, they're all important, but this one is really important, number three, called amount concentration, which is measured in moles per liter. So we're going to go through each of these, look at some examples. So hang tight, I'll be right back with the first example for the first type, percent concentration. So as you can see here, percent concentration has three ways that we can calculate it. So the first way is called weight to weight, the second is volume to volume, and the third is weight to volume. And so the number one underlying concept you need to remember about all three of these is that whether it's the weight or the volume, the solute measurement must go on the top of the fraction. Remember, we're calculating percentages here. So anytime you calculate a percentage, it's a ratio times by 100, just like you would do if you're calculating the percentage that you have on an exam that you wrote or something like that. It's always how many right out of how many wrong times by 100. So these are ratios. The solute always goes on the numerator and the solvent always goes on the denominator. You can see that that is the case for all three types of calculations for these percent concentrations. For the weight to weight and the volume to volume, you have some flexibility in the units that you want to use. The one rule that you have to remember that kind of relates back to some lessons that we talked about in the gas unit is that the units must be consistent. So if I'm expressing my solute in units of milliliters, then I must express also my solvent in milliliters. Or if I choose to express my weight here in grams for my solute, then my solvent also has to be expressed in grams. I can't have grams per kilogram or milliliters per kiloliter or something like that. For percent concentration, the units must be consistent if it's weight to weight or volume to volume. For weight to volume, it is a fixed set of units that you have to have, and it's because grams and milliliters are related in the sense that they're the same for water. And so my solute has to be always in grams and my solvent has to always be in units of milliliters. So some things that you have to watch out for in terms of units to make sure that you are calculating these answers correctly, and something that you must always double check when you're doing these practice questions. So I'll be back with some examples from each of these three types so that you can get a sense of how they work and what's expected of you. I'll be right back with your first couple of examples. Okay, so we've got three examples up here on the board that illustrate these different types of percent concentration calculations. One thing I wanted to point out that I didn't in the previous clip was that this concept of weights. So I'm not really wild about how they call these percentages weight to weight because weights and masses are really two different things. And you would have learned this in Science 8 and maybe other science classes that you've taken, option classes, where weight and mass are two different things. And you know, if we're talking about someone's mass on Earth and someone's mass on the moon, it stays consistent. But someone's weight on Earth and someone's weight on the moon is totally different. And so for whatever reason in this concept, they like to use mass and weights sort of interchangeably. So where you see weight, really what we're doing is we're using masses, but they do express these percentages as a percent weight to weight ratio so that you know that it's using masses, not volumes. So just keep that in mind as we're kind of going through these examples. So this first one right here says that we've got a sterling ring that's 12 grams in weight or mass. And it contains 11.1 grams of pure silver. So when they make these sterling silver rings, they'll melt the pure silver in with other metals, mix it all together so you can't see the different parts, so a solution. And then they dry it out, obviously cooling it down as well. Not dry it out, but cool it down so that it hardens into a metal ring. And so you can calculate the percent concentration of this in a weight to weight ratio. So you can see here, again, remember that we need the weight of the mass of the solute on the top and the mass of the solvent on the bottom. And if you wanted to, you could put masses here. I'm not really going to be super worried about it. And this is not really anything that I'm requiring you to show in your work either. But starting right here, for sure, you need to plug the numbers in and you need to show that work. So 11.1 grams is how much is the mass of the solute. 12.0 grams is the mass of the solvent, and then you just multiply it by 100 to get a percentage. And in this case, we get 92.5, making sure to round your answer to the correct number of significant digits. 92.5% weight per weight, or weight to weight. And what I've circled here is what needs to be written in order to get full marks for a question like this. If you were to stick just 92.5% and end it right there, that would be incomplete, because looking at this percentage, if nobody had these numbers, they wouldn't be able to tell whether that percentage was from volumes or from weights. And so it's really important when you're doing percent concentrations that you illustrate what percent concentration it is that you are expressing. This is expressed as a weight to weight percentage, so we have to illustrate that within our answer. The second one is a volume to volume question. So a stop bath is just like a bath that photographers use to develop photos and things like that, and it contains 140 milliliters of pure acetic acid in this example in a 0.500 liter or half a liter bottle of solution. So within that half a liter bottle solution, there's 140 milliliters of pure acetic acid dissolved in that solution. It wants to know what's the percent concentration of the acetic acid solution. And they want it as a volume to volume expression. And so if I'm doing a volume to volume, then I need to use volumes. Now the one thing I want to point out, as was mentioned in the clip before, is that this here is expressed in liters, and this number here is expressed in milliliters. So when I plug these into my formula though, remember weight to weight or volume to volume have to be consistent units. Now, if you want to choose liters or milliliters, doesn't matter as long as the units are consistent. I chose milliliters for this one, so I went 140 milliliters divided by 500 milliliters, remembering our lesson on unit conversions that we did several months ago. And then you multiply that by 100 again to get your percentage, and you end up with 28.0. The 0.0 is important because of significant digits again, volume to volume. And so then there's my expression of my answer there for that one. Now this last one right here is a little bit of a twist. Instead of giving you both the volume and the volume, or the weight and the weight, or in this case, a weight and a volume to calculate a percentage, they've given you the percentage, and it wants you to calculate what's the mass of fructose, so the sugar that's in apple juice, what's the mass of fructose in 175 milliliter sample of that juice. And so the way that I like to express or show kids how to do stuff like this is really just like, if you think about it in terms of calculating a percentage for an exam. Like, for example, if I told you that you got 12% on an exam, which hopefully this doesn't ever happen to you, but let's say hypothetically a student gets 12% on an exam. Well, we know that that percentage is expressed as a decimal, when we're expressing it as a real number. 0.12 is 12%. And if we want to know how many questions the student got right, we would need to know how much the test was out of. So if the test was out of 175, then algebraically I could quickly solve for that, x, and figure out how many questions the student got right. So for this question, it really is no different. Instead of talking about percentage on a test though, we're talking about the percentage in apple juice. So I know that this is a weight to volume expression. The weight is the solute. Now because it's solute and solvent, because this is a weight to volume expression, these units have to be specific. So I know that the units on the top for the solute must be in grams. And so whatever that number is, it has to be in grams. And whatever this number is on the bottom, it has to be in milliliters. And so it gives me the volume of the solvent, which is the apple juice. And it says it's 175. And it says that the percent concentration of this weight to volume is 12%. So I know that if I just divide this number divided by if I take this number divided by 175, that should give me the 0.12 that I'm looking for. Now I could times it by 100, but I don't need to. I don't want to because I don't want to deal with 12. I want to deal with the number 12%, which is 0.12. So this divided by that should give me 0.12. So if you want to simplify this a little bit and just sort of now that you've got the units in there and you've understood what units are what and where they go, you can sort of just take those out and quickly algebraically solve for this by just doing some simple math like I had on the board before. So x divided by 175 gives me 0.12. And when you plug this into your calculator, you'll see that x is equal to 21. Now, what are the units of 21? Well, if I go back up here to my ratio, because I've properly put in the units where I was supposed to, that should tell me, oh yeah, this is going to be in grams. 21 grams divided by 175 milliliters is going to give me 12%. And so I know that in the apple juice, there's 21 grams of fructose or sugar found in that sample. So this example actually was question number 3 on your practice booklet, and so you can kind of follow along with that. There's a follow-up question, question number 4, that you can use where you will use some of the data from this question in the following question to help you calculate something else. But all in all, that's all you guys need to be able to do. You should be able to either calculate the percentage, or if you're given the percentage, be able to calculate either the volume or the volume of the solute or the solvent, or the weight of the solute or the solvent, given what numbers you're given in the question. So good luck, and we'll see you guys with the next concept coming up shortly.